doing a bunch of interviews recently and recording them, but fully a third of them I forgot to hit the record button.
So greetings, folks. If people can mute themselves, that would be awesome. During the talk, feel free to mute and unmute yourself to ask questions. And let's see, a couple of just housekeeping before we get started. This week, I'm sort of disappointed that we had some inappropriate pictures posted in the Meetup, and I got rid of them as quickly as I could. So I apologize if you saw inappropriate pictures. And there's limited amount of things we can do about that. We do have a code of conduct, and at some point we're gonna we'll chat about it and make it available. But it's sort of the common sense stuff in it. This Meetup, it is a safe space. I'm going to work like heck to keep it a safe space. All of the usual common sense. We try to keep isms and bullying and any of that kind of nonsense out of here because we're techies. So we will formalize that, but know that we take that really seriously. We're going to have 2 AWS gift card giveaways towards the end of the evening. Let's see, does anybody have jobs that they are, does anyone have job openings? Please, if you do, just, say so. Also post it in the chat here, and also post it in the jobs channel in our Slack. So anyone have jobs?
I don't. First, I have a good friend of mine who's on the hunt for a web app developer.
You're really breaking up.
That does not sound good. Choppy.
Got it.
Okay. You can also just post your job in the chat if the sound doesn't work.
So Arana, I think you're okay now. Do you want to try it again?
Sure. Oh.
Yeah, it's the toggling of the mute.
Maybe that's it. Is that better? Hey, all right. I have a friend who's looking for a web and app developer up in the New Hampshire area, right over the Massachusetts border. So if anybody he's looking for a team lead web and app developer. Anybody who knows anybody, please send them my way.
Okay, if you could put your contact in the chat, that'd be awesome.
Absolutely.
Anybody else?
I'll throw up the opposite side that my son, who's a recent graduate with a cybersecurity degree, is still looking for his first entry-level job doing something with cybersecurity in any way, shape, or form. So if anyone knows anything, let me know.
Okay. One other general announcement, reInvent is now officially virtual. So I understand, but I'm incredibly disappointed. I love reInvent, but it's virtual, and we'll see what that entails.
Where did you see that?
Jen, you didn't know?
I know. I've been slammed.
Yeah.
It's
No.
posted.
Yeah, they posted it.
Ooh.
Most is good though. It's 3 weeks, so there's space in it.
Right, that might allow us time to get between the hotels. But anyway, so perhaps.
Oh, and it's free.
Well, yeah, and it's free. Yeah. Let's. If there's nothing else, so we're going to. We're very lucky to have Kunal, if I'm saying that right, from Amazon, talk to us about introduction to ML with AWS. I do have my DeepComposer. Sadly, my DeepRacer is still stuck at the office, and I don't work at that office anymore, so I'm probably never going to see it. But we're very lucky, and I'd say, why don't you take it away?
Sounds good. Thank you, Brian. Let me know if you can't hear me or the audio flakes out at any point. And also feel free to just ask questions and unmute yourself as well during the presentation. All right, so let me go ahead and share my screen. I am giving this off my laptop, so I don't have my dual monitor set up here, so you see everything I'm seeing. Excuse me. Let me make this full screen. All right, does that look good to everyone? Perfect. Okay, so how's everyone doing? My name is Kunal Batra, and this is going to be an intro to machine learning for AWS, plus the DeepRacer and DeepComposer. So we'll do a little bit of what is ML here at AWS and spend the majority of the time on the DeepRacer and DeepComposer. Just a little bit about me to calibrate for any of the questions or conversations we might have during this presentation or afterwards. I am a senior developer advocate here at AWS. If you've never heard of the role developer advocate, essentially an engineer who builds awareness and adoption. I worked on a lot of different developer-focused verticals in my career. So if you have any questions on any of those, feel free to reach out. Excuse me. At Kunal732, my Twitter handle is by far the fastest way to get a response from me. You can also email me, kbatra@amazon.com. And then personally, I'm really into machine learning and computer vision. You can see a photo on the bottom left of that slide there, and that's a model I built for my parents to let them know whether the garage door is open or closed. It's one of my first AI models here at AWS, and they love it. Another one to the right of that is counting how many people are online at the Shake Shack in Madison Square Park. And then this is one that I just built recently. It's an object detection model for some household items I have in my apartment, just so I don't misplace them. So this is a passion of mine. If you have any questions on any of those, feel free to reach out at any point. Okay, so let's begin. Our mission here at AWS is to put machine learning in the hands of every developer. So whether you are an experienced machine learning data practitioner, or you're an everyday developer without the machine learning expertise, we want to have the tools to make sure everyone can enable machine learning in their applications. And to do that, we think of machine learning here at AWS as in this stack, these three layers over here. So if you look at that top layer, these are AI services. These are APIs and SDKs that any developer can integrate into their applications. Recognition is personally one of my favorites. We just recently added a new feature called custom labels that really lets you do a lot of those powerful things like building those garage door apps or detection models without having to really play around with any of the frameworks. So I recommend checking that out if that's something you might be interested in. Now, if we move to one layer lower, you see the machine learning services. Now, these are a suite of tools under the umbrella of Amazon SageMaker. And these tools make it easy to build, train, and deploy machine learning models. So after this, we're going to see that first service labeled there called Ground Truth, which is by far my favorite service at AWS altogether. And it's the least sexiest service, I would say. It's nothing to do with the AI aspect of it. It's for that labeling aspect, which is a really hard problem. Now, if you look at that last layer on the bottom, the ML frameworks and infrastructure, these are for the advanced data scientists and machine learning practitioners, really for those people who are really comfortable at that framework level. So you can see the frameworks TensorFlow, MXNet, PyTorch. We have teams dedicated here at AWS specifically for each of these frameworks to make sure they run in an optimized way on the AWS cloud and they can be deployed on the AWS cloud itself. So that's the machine learning stack here at AWS. Let's focus in a little bit on Ground Truth, just to showcase what it is. I think it's a really powerful service for all machine learning practitioners here. And so when we talk to our customers at AWS, they let us know that 80% of the time it takes to build and deploy a model actually comes from that data labeling phase. It's just too time consuming. So a lot of the questions that people wonder when they start labeling their data sets is how much of that training data do they need? And you have to think about what's the cost of making a mistake, right? So if you have a self-driving car, if something happens, is 99.9% good enough, right? If something goes wrong 1 out of 1,000 times, is that okay, right? It's not. So you need a lot of data, right? And you want to make sure that you have an accurate data set, right? You want to make sure that you have a diverse set of inputs, different conditions, and this can be a lot of data that you need to get sampled. And with such a large sample size of data, there are issues that can arise when you're trying to get that labeled by a human workforce. So we have a service here called Ground Truth that does a couple of things to simplify this, right? It gives you access to human labelers to help simplify that. It has these templates that lets you quickly label that data. It has certain algorithms that make it accurate. We'll talk about that in a second. And it also has the ability to also learn while a human workforce is labeling to help reduce those costs. So let's go into it. So I mentioned those templates, right? So depending on what your use case is, we have different templates that you can give your workforce to really help simplify that process for labeling data. So bounding boxes for detection, we have templates for image classification, text classification, semantic segmentation. Semantic segmentation is where you want to know where an object is at the pixel level, not just with the bounding boxes. And then you can take advantage of our templates and make it work for your own workflows, right? So I've seen this used for audio classification as well from our customers. And we keep releasing new templates. It's not on this slide, but now we have the ability for labelers to label video as well. The next thing Ground Truth does that's really powerful is it gives you access to the pool of labelers, right? So you can take a look at Mechanical Turk. So Mechanical Turk is a workforce of 500,000 strong. This is great if you want something fast and quickly labeled. However, it's not great for sensitive data. So make sure that if you want to take advantage of Ground Truth, your data is not sensitive and it's not something that you want to keep private. It's also lower in cost, so you can definitely save money if you have the correct data that can be labeled with Ground Truth. The other thing is it's not great for any application that requires subject matter expertise. If you need something that requires certain subject matter expertise, you can use a private workforce. This is essentially people in your own organization who have that subject matter expertise. Also, if you have sensitive data that you can't distribute anywhere else, that is a great option. Also, this is the cheapest option because this is your own workforce. You can also take advantage of third-party vendors as well, and they have different types of expertise or support plans that might make sense for your organization. So this is where I usually turn it to the audience when I'm giving this talk in person. But let's say that you're a labeler and you see the image of that dog over there. What do you see, right? Is that a bulldog? Is that a Shar-Pei? In this case, you can see that we've had 4 labelers over here. 3 of them said bulldog. 1 of them said Shar-Pei. But the problem is that this is actually a Shar-Pei. It's not a bulldog. So in case of majority voting, which we've seen a lot of our customers use, this would be labeled incorrectly. Now with Ground Truth, we take advantage of the Bayes rule and probabilities and actually a modified version of an algorithm called expectation maximization. And I'll give a link to that paper of that algorithm that we use. But with that, we start taking a look at the accuracy of the labelers who are labeling in our system. And then we can see that in this case, the labeler who said Shar-Pei is actually more accurate than the other 3 labelers. So in this case, with probabilities, you see that even though 3 out of the 4 said bulldog, it'll still get labeled correctly as Shar-Pei in this case. So if you want to learn more about that particular algorithm, there's a great paper on it, Expectation Maximization, proposed by DeWeed and Skeen. I have a link there. I'll make sure to put this link in the Meetup page as well for this presentation. Recommend checking that out too if that's something you're interested in. And then finally, Ground Truth has this ability to help save you cost as well, and it comes with active learning and auto labeling. So if you take a look on the left over here, you see that data set of, in this case, dogs, and you want to be able to detect dogs in this particular model, right? So your labelers will go ahead and start drawing bounding boxes around each of the dogs, which is great. It'll go ahead and label that data. However, like we mentioned earlier, these data sets, you need large amounts of this data, and this can get quite costly to have labelers label every piece of data. So with Ground Truth, you can set it so if it hits 1,000 or more pieces of labeled data, it'll start activating active learning. And essentially what's happening here is after it hits 1,000, it's going to start creating a model. It's going to start learning, creating this computer vision model. And then from, instead of sending it directly to the labelers, it'll go ahead and send it to the computer vision model. And if this is accurate, that's great. It'll go ahead and send that to the label data set. If it's not accurate, and you can adjust what confidence level you want for it to be, go directly to the label data set, or if you want it directly to go back to the labelers as well. So it'll keep learning and it'll keep going through this process until it gets accurate enough where it can just go ahead straight to the computer vision model and doesn't have to send the data set to labelers. So this is called active learning auto labeling. It saves quite a bit of cost as well. So I have this link over here for a demo. It walks you through these instructions and how to create a simple cat dog labeling job. And it works with Mechanical Turk. It'll cost $1.20 to go through this demo. In this case, I'm just gonna close the presentation here, and I'm just gonna show you Ground Truth and this example of Ground Truth that I was working on. So I have this data set here, and I wanted to label these deck of cards. So I took a video, and I broke up that video into frames. And you can see over here, this was 586 frames. I just uploaded that to Ground Truth, and then I got this data set labeled, right? So you can see some of my, me holding a deck of cards here. And if I click on one of these frames, you can see what it was labeled as, right? So 6 and 10 over here, it was human annotated. This was done for me. And let me show you what the labelers actually see over here. So if I click on View Labeling Tool, this is what a labeler sees. They came to this particular screen. This is the template. They go over here and they say, okay, I see a 10 over here. So let me go ahead and make sure I can draw a bounding box on this. And this is a 10. They see, oh, I saw myself over here. So let me go ahead and draw Kunal over here. And then a 6. And they do this, right? So you can go ahead and label this yourself if you want, but it'll take a while, especially with the larger data sets. So in this case, you can just send that to Mechanical Turk, and then from there, it'll go ahead and label that for you, which is really powerful. Now with this label data set, you can do a couple of things. You can use other tools in SageMaker to kind of go ahead and train models, an object detection model with this. Or you can go ahead and send it to that top level of services. There was Amazon Recognition, and just basically point it to this data set and it'll automatically do everything for you. It'll give you an API, an endpoint that you can hit. You send it a photo and it'll give you back where those objects are for that. And it's really cool, really powerful, and simple to use. And depending on your use case, that might make sense for you. So that's Ground Truth. It's one of my favorite services just because it takes one of the hardest parts of AI/ML and just really helps simplify that and make it easier for me. So let me go back to my presentation here. Switch over back to PowerPoint. So that was Ground Truth. Some more resources here that you can check out when you see this presentation. There's a bunch of GitHub examples and a great blog post to learn more about Ground Truth as well on this. Now, the next thing I want to talk about here is our educational devices, right? So we have those 3 layers of machine learning services here at AWS. But for a lot of people, this is brand new to them. And before they can go ahead and start taking advantage of those services, it makes sense to kind of see it in practical application, something that might make them understand what it is right away, right? So right when we introduced SageMaker, this was our thoughts. We literally wanted to put these algorithms in the hands of developers. So back, I believe it was in November 2017, when we introduced SageMaker, we also introduced the Deep Lens. And the Deep Lens is great because it lets you understand image classification and supervised learning. And then afterwards, the following year, we introduced the DeepRacer, which is great for, it lets you learn about reinforcement learning through it. And we'll talk about the DeepRacer in this presentation. And then last year, you saw Brian hold up his DeepComposer keyboard, and that's for generative AI. I don't have the keyboard in front of me, otherwise I would show it to you, but it's pretty cool. Brian's, there you go. Yeah, that's the keyboard right there. So these are our machine learning devices. It's a way for us to teach our customers and our developers, showcase the use case of it. And if you want, you can take advantage of that use case and break it down into your own applications as well. We also have training and certifications that you can take to learn more about machine learning as well.
Quick question. And sorry if this is naive, but what you're showing is all based on image or vision learning. Are there any examples of using this for non-vision type data?
Yeah, so for the DeepComposer, that's music.
Okay, so there you're using frequency learning, so to speak.
Yeah,
the data set that we're working with is all point clouds. So I'm curious if you've seen examples of that.
So with Ground Truth, we just introduced the ability to work with point clouds, but in a lot of our examples here, especially for teaching intro to ML, a lot of it is vision based, like you mentioned. Yeah, I mean, you can take advantage of SageMaker with any sort of data set that you want, whether that's tabular, whatever that may be, you can go ahead and work with that. In a lot of those other services, some of it is vision-based, some of it is also tabular data, nothing audio, text-based, but that's it. And then DeepComposer is music.
That auto labeling that you showed earlier, is that only for images?
The auto labeling is for anything. It's not just images. You're talking about the active learning for Ground Truth?
Yes.
Yes. Yeah, that is for anything. Text classification, whatever it may be.
Thanks.
Of course.
I'm going to ask a question, and this may be jumping ahead, and please feel free to tell me, just wait. But I got a DeepRacer, and I did play around with coding with it. And for folks who aren't familiar with DeepRacer, you either in reality or virtually teach it to drive a track, and you have a reward function that says, you know, hey, my wheels are on the track, my wheels are off the track, hey, I'm pointing in the right direction, and so on and so on. And it was interesting, and it sort of made sense to write a reward function that did a better and better job of staying on the track. And that made sense. I will say, when I played with the DeepComposer, I had no idea what I was doing, and I am a musician. And it's like okay, so I banged out some junk and then said, go make it pretty, and it made it pretty. I'm like, okay, wow, I'm an AI guy now, and I sort of didn't get it, and I can wait, but I'll just put that out there.
Yeah, and I'll touch upon that too. So one of the issues we have, I mean, not one of the issues, one of the things I've seen with our educational devices. So for the DeepRacer as well as the DeepComposer, we really handhold you through that process, especially with the DeepComposer, right? Like we give you the option to choose between the MuseGAN and the UNet, two different types of networks, but that's it. We don't give you the ability to give you your own data set. We have a link where we walk you through this GitHub tutorial on, you can use SageMaker to do that, but in the consoles, there's a lot of hand holding with it, right? So that's one of the things to keep aware for the educational devices. They're more meant to kind of give you that inspiration and showcase this is what can be done. And then there's usually GitHub links to either SageMaker notebooks, where you can kind of see what's happening behind the scenes and see, okay, how do I create my own data set for the DeepComposer, by the way. So when you play your own music notes, how do you make it sound like something that's not a genre that it gives you, right? Like Bollywood, for example, right? How do you make it sound like that? So that's not available in the console, but if you do take a look at the SageMaker notebooks, you can see that you can go ahead and start playing around behind the scenes with what's going on. So for the DeepComposer, this is using something called Generative AI. And for the DeepComposer specifically is using GANs, Generative Adversarial Networks. And for Generative AI, there are a lot of practical use cases that we've seen our customers use. For Airbus, they use Generative AI for part creation. We've seen NASA take advantage of Autodesk to use Generative AI for helping with that design process to create ships that can go to, in this case, Jupiter, which is 365 million miles away. And then also Guildwell, which is a dental company. They use generative AI to take photos of teeth and generate 3D models from it as well. So there's a lot of interesting use cases for generative AI. With a DeepComposer, now we're trying to apply generative AI to music, kind of like we already mentioned here, and we'll showcase that in a bit. So the keyboard that you just saw, here's another photo of it. It's a 32 key 2-octave keyboard. I feel like I've seen this keyboard online as well, but if you get it from AWS, we have that little AWS logo there too. You don't need that keyboard. You can take advantage of the console too, right? So this is the music studio in the console where you can use your own keyboard and play around with this. And essentially what you do is you create an input melody with either your keyboard or the music studio. Then from there, you choose a different type of genre, jazz, rock, pop, classical, or you can build your own with SageMaker. And then it goes ahead and takes your music and it makes it sound like it's part of that genre with the DeepComposer. And this is just to showcase an application of generative adversarial networks. From that, so you can publish that track to SoundCloud if you want. We have one of our user group leaders in New York City. I don't know if anyone here knows Martin Paradisi. He has a YouTube channel where I think at least twice a week, I see new videos being posted of different types of music that he's created through DeepComposer. So definitely check that out if you want to get some inspiration on what you can do with it. Everything here does have Intel inside. And there are different types of generative AI, right? So there's autoregressive, there's variational autoencoders, and there's also generative adversarial networks, which is what we're going to discuss over here. But to give a little refresher of machine learning for people who are new to this, machine learning falls into a larger subset of artificial intelligence. And artificial intelligence is any sort of computer system that can mimic human behavior. It doesn't have to be neural networks. It can be a bunch of if and else statements. Now, when you go one subset lower into the machine learning, now you're starting to learn with data. And inside of machine learning, there are three real popular algorithms here. So you have supervised learning, where every input that you have needs to be labeled. So for example, when I created that garage door open or closed model, that was an example of supervised learning. Different types of photos of the garage door open, different settings, so cars there, not cars there, daytime, nighttime. And so each one of those data is labeled. Unsupervised learning is something different. You don't need labeled data. You can just take a look at the attributes of your input and cluster it based on similarity, for example. Now, reinforcement learning, this is the DeepRacer, and we'll talk about that after the DeepComposer. In this case, you're learning through the consequences of your actions. So with generative AI, you can see this as an example analogy to a GAN, right? So in this case, generative adversarial networks have two networks inside of it. You have your generator and you have your discriminator. The backdrop in this slide, you see behind the generator is an orchestra, and the backdrop of the discriminator, you see the conductor. And essentially, this is just an analogy over here. The orchestra needs to create music that the conductor in this case, or the discriminator, will say, yes, that sounds like real music of this type of genre, good job. Or no, that doesn't sound like real music, false. And then it takes what the discriminator says, and then from there it trains both models together, and it keeps getting better and better. In this case, when GANs just start out, that generator just takes random noise in the beginning and just keeps outputting random outputs. and the discriminator says false, false, false. And over time, the generator gets better. And also the discriminator is getting better at saying what's right and what's wrong. And that's the idea of generative adversarial networks. In this case, the idea of an orchestra getting better and better. And the conductor is also getting better at telling it what sounds good and what sounds bad. Right, so we saw how this works. So let's see a quick example of this. And like I mentioned with the DeepComposer and DeepRacer, we really hold your hand in this, but that's not the point of this, right? We want to give you an idea and inspiration of how this could work. But at the same time, we do make sure that we point out notebooks. I'll showcase that where you can kind of play around with this yourself. So let me go back here. And again, I always start off console.aws.amazon.com. That's how you access everything. From here, we're going to go ahead and type in the DeepComposer. This takes us right away to the DeepComposer screen. We're going to say get started. And when you say get started, you see a couple of things. This first box over here walks you through the basics of generative adversarial networks, very similar to what we spoke about today. It also it has a couple of little fun quizzes in there where you can do two different types of music, and you have to decide which one was the one created by a computer, which one was the one created by a person. So I recommend playing around with that if you get a chance. Below that, you're going to see the music studio. This is where you can go ahead and kind of just create new music if you don't have your DeepComposer keyboard. On the right-hand side, you can train a model. This is what we're going to do. Below that, you see this section where you train a model in SageMaker. And this is what I mentioned, right? So this is where you can actually play around with what's happening behind the scenes. So for now, let's go ahead and click train a model. And in this case, when we want to generate music of a certain type of genre, the first thing we need to do is choose between two different types of GANs, those two different types of networks. We have the Muse GAN, and the Muse GAN was specifically created for generating music. Or you can choose the UNet, and the UNet wasn't meant in the beginning for generating music. This was meant for images, but this also works here. So let's go ahead and choose Muse GAN. You can learn a little bit more about the architecture of this network. Next, what you want to do is create a training data set. So this is what the conductor will say, or the discriminator will say, okay, does this sound like symphony? Yes or no? And then the generator will get better at making it sound like symphony. Jazz, pop, or rock. We already have these 4 built-in training data sets, which is nice, but this gets really fun when you can build your own training data set again, right? So on the previous screen, if you click on that bottom right link for SageMaker, you can see how you can go ahead and use your own training data set for this. For now, we're just gonna, yes.
I'm sorry, this may be super naive, but is the initial input or is the dimension, I guess is what I'm trying to say, a sequence of notes for a particular duration at a particular time? I'm just trying to understand, like, what does the data look like that we're working with here?
That's a great question. So let me just—
as opposed to the tone of the vote, and the instrument and so on.
Yeah, that's a great question. So what it's doing over here is it's actually converting this into an image. So can you see, if I zoom in on this, it's actually converting this into a piano roll where it shows these different notes over time. And then from that image, it goes ahead and generates generates another image based on that. So this is actually the data that you're looking at over here. Ken, does that answer your question?
It does, and it's not at all what I expected, right?
Yeah.
I didn't think you're going to be moving it into an image. Is that a kludge, or is that just a typical way that these things are done?
So that's a good question. I had the same question when I was starting to look up on both the MuseGAN and the UNet. In this particular case, that's how it reads the data for this, I guess because it's more simplistic, these piano roll images. But that's what we're using here. I'm not sure if all music generative adversarial networks learn like this, but in this case, that's what these two are.
Okay, thanks.
The next thing over here, once you choose that data set and what you want your music to sound like, you can go ahead to the next box and modify the hyperparameters. These are just the variables that your machine learning network uses to learn. You can get more information on each of these over here. Right now, we're going to leave it as default. And then you can give it a name. So we're going to call this sample. What do we pick over here? Sample Symphony. Let's make it custom Kunal. And then we can go ahead and train this. So let me just move my Zoom sharing thing here. Okay, so start training. Oh, I already have a job training right now, so let's go ahead and take a look at that. So right now I already started training, and let me showcase one that's already done. So in this case, I tried to make it look like rock. So now this model is already done. Let's go ahead and create a composition with this model. We have an input melody already here for us. By the way, let me know if you can't hear the audio on my computer. I've had this happen before. Let me press play. Okay. So Twinkle, Twinkle, Little Stars, we all know how that works. In this case, we want to take advantage of the GAN. From here, we're going to go ahead and take advantage of Kunal of Rock, the model I trained, and we're going to go ahead and generate a composition. It's going to add these accompaniments to go ahead and make it sound like rock. And then we press play. So that's an idea of how this works. That's rock, or what sounds like rock, based on our discriminator. If you do want to go ahead and play around with this with your own data set, I really recommend that. I think that would be a little bit more fun to do. So that's essentially the DeepComposer, and kind of showcasing you how GANs work. So again, these deep learning devices, they all kind of coincide with an algorithm that we released with SageMaker. So when we released reinforcement learning in 2018, we introduced the DeepRacer. Generative AI in 2019, we introduced the DeepComposer. All right, so let me switch back to my PowerPoint presentation here.
So on that concept of having a SageMaker notebook to correspond, does that also apply for pretty much like everything you see in recognition, for example, or even like comprehend? Can you get? Yeah. I haven't looked through the whole catalog of SageMaker models, but is there essentially a model for all those high-level services that you could just drop down to?
Good question. So yes and no. For a lot of them there are, some of them they're not. For recognition, I don't think so. Not for all of them. Now, a lot is available. Recognition kind of does a lot for you behind the scenes and takes advantage of other data sets that we have, and does something called transfer learning, where you build on top of that as well. Now, you can go ahead and do that with SageMaker, but that's not something that's available to you to do. For a lot of those AI services on that top layer that I spoke about, a lot of those are with data and other things that we've built internally here at Amazon.com for the last 20 years. So some of them, it might be available, some of them, it's not going to be available. All right, so let me switch back to my PowerPoint presentation. That was a DeepComposer. And let's go to the DeepRacer. All right. The DeepRacer, so again, back in 2017, we introduced SageMaker, and we wanted to make this literally put in the hands of our developers. We came up with the Deep Lens. And in 2018, we came up with the DeepRacer for reinforcement learning. As of right now, this is how the latest DeepRacer looks like. I personally don't have this one. I have the previous generation of this. For those of you who are familiar with DeepRacer, have it, you can see some changes here. It has stereo vision, so there's 2 cameras. You can also see that circular thing at the top over here. That's LiDAR as well. So this is a bit more accurate than the previous generation of the DeepRacer. And if you have a concerning or a sharp eye here, you can see that that camera looks very similar to the Deep Lens camera. It's actually identical, the camera there. So this has 2 cameras in there. Also, if you do have the original DeepRacer, you know that there's actually 3 USB ports in the front over there, and the idea from the beginning was to have this, for this to have stereo vision. So the DeepRacer is actually a couple of things. It's not that 1/18th size race car that I just showed you. It's also a 3D racing simulator. It's an AWS DeepRacer League. You can go to deepracerleague.com, see more. And you can also host your own community races with it as well. So let's go into a little bit of reinforcement learning. We already saw this slide before, but again, there are 3 real popular machine learning algorithms here. Now, reinforcement learning, this is learning through the consequences of your actions. And this is actually something very similar to what we've seen in real life as well. If you do have a pet dog, for instance, you would reward it for positive behavior. You wouldn't reward it for negative behavior. And I didn't create the slide, but it looks like it's a well-trained animal, I guess, in that photo of the dog that looks kind of scared. But that's the idea, right? So you want to reward it for positive behavior, not for negative behavior. And that's very analogous to reinforcement learning. Some common terms that you hear with reinforcement learning, you have an agent. In this case, the agent is the car. Now, this agent works in an environment. This environment will be the DeepRacer track. And it wants to achieve a goal in this environment, which would be to complete this track, to go around the lap. The state is a snapshot in time. An action is an action that the agent can take. So in this case, forwards, backwards, left, right, change in increments of speed. The reward is a value that we give the agent, so it gets closer to a goal, right? So the goal in this case would complete the track. So a reward might be, hey, if you stay in the center of the lane, you get rewards. And we'll see this in a bit. An episode is the start state to a termination state. So the starting state where it starts, and it could go around the track, that's an episode, or it can go off the track. So it's a termination state, so that's an episode. And the idea of reinforcement learning, the crux of it is the reward function, right? So as Brian mentioned earlier, you want to give a reward function that incentivizes a particular behavior. Ideally, this behavior is going to be going around the track as fast as possible so you can win the race. So here's a really simplistic version of the DeepRacer happening. So you have your agent starting, and this is a really simplistic track. You want it to go ahead and complete this track as fast as possible. You see right away that if it goes in a straight line, that it'll complete the track as fast as possible. So you're going to create a reward function for it to do that, right? So you want it to go straight. If it goes anywhere off that, it gets less of a reward, and it's not going to incentivize to do that. So in the beginning, the DeepRacer doesn't know anything, right? The model doesn't know, the agent doesn't know anything. So it starts taking random actions in the beginning. It starts understanding its environment, and it just keeps iterating and learning based on certain actions that it does what's happening. After a while, it starts exploiting that knowledge, and then from there, it learns that if it keeps going in this straight path, it'll get the maximum reward score, right? So that is the basics of reinforcement learning here. And this is just showcasing exploration versus exploitation, right? In the beginning, your car is going to just keep going off the track right away, over and over again. But then after a while, it's going to go ahead and start exploiting that knowledge and be able to actually start moving on the track based on the concept of your reward function. So what's happening in the background over here? Your agent is taking an action. It's doing this 15 times a second. It's taking action in the environment. Every time it takes that action, it takes a snapshot. It checks its state, and the state is kind of, if it's the older generation DeepRacer that has the one camera, it's taking a look at just this 120 by 160 image. Otherwise, it's taking a look at these 2 stitched images of the stereo vision plus the LiDAR. And then from there, it's just kind of seeing what state it's in, and based on the state, what reward does it get if it's closer to its goal or not, based on a reward function. It's doing this 15 times a second, and it's training that model. Was there a question? Perfect.
Actually, I'll just say that watching the car go off the track just sort of made me twitchy from so many hours of trying to train my device to go on the track. And you know, it would initially just have not a freaking clue, and then it would start going along, and like you'd see a curve coming up. And it's like, yes, it could take the curve. And then it was like, hey, it learned how to turn left. And then we put it on a different track that had right-hand turns.
Yep.
And it had no idea whatsoever.
Yep. Yeah,
and
exactly.
And the other thing that really, I mean, it was educational, was that you can, when you set up the car, you can use a real car or a virtual car. And with the virtual car, you can say how many degrees of speed it has, how many degrees of turn it has. And so I said, well, I wanted to have all different speeds and all different turns. Well, my search space just, exploded. And so it actually did much, much worse for a while because it hadn't spent any time at all in the search space relative to the size of the space. So from that point of view, it was very interesting. I never got very fast, but.
Yeah, yeah. And what Brian's mentioning over here is the amount of actions the car can take, right? So if it can only take 3 actions, it'll learn faster. If it has the option to take many, many actions, it takes longer for it to learn to find that optimal solution. Another thing, I get a lot of questions about this. The actual training only happens in that simulated environment. It doesn't actually learn in real life with the actual car. At that point, it's just making inferences on what it sees, but there's no learning happening there. It's actually when it trains that model on AWS in this simulated environment, that's where it's learning. And this is the architecture behind it. Again, this is another computer vision architecture. This is convolutional neural networks. You can see that outer the last layer over here, those are the actions it takes. So it feeds in this input. Basically, your car, when it's on the actual track, it'll go ahead and take an image of every 15 times a second. Based on that image and what it's learned in the training, it's going to say, which action do I take? Do I go fast? Do I go speed up? Do I slow down? Do I go left? Do I go right? And then the rightmost layer over there, there's the action to take. So basically, you train it on a particular track. It learns how to do that track pretty well. And then from there, it takes actions on that. Now you put this car on a different track, it's going to see inputs it hasn't seen before, so it might not operate as effectively. Yes, go ahead.
On the feature extraction, couldn't that be, I mean, would you be able to do transfer learning, assuming that the feature extraction is pretty similar across the tracks, and then just do the actions at the end would be the ones that you'd
So you're just modifying like one of the later layers?
Mm-hmm.
Yeah, it's possible. In this case, kind of it's just going through the full process right here, right now. Okay, so let me showcase this. So let's go to the, sorry about that. Okay, so we're at the DeepRacer. We're gonna go ahead and click Get Started. So the first thing you see with the DeepRacer, again, it puts you through this educational component over here. It's actually pretty cool. I recommend checking this out. Let me go ahead and actually load this up for a bit. I want to showcase something in a bit here. But okay, so there's this educational component first. Then from there, you can go ahead and create a model. And this model walks you through in the beginning some of the similar concepts that we just spoke about. In this case, you can just put in DeepRacer Boston. You can choose which track you want to train it on. So there's multiple different tracks here, and these are changing, and they're new every month, or they're definitely changing quite a bit. We have the original track all the way in the bottom right over here, the reInvent 2018 wide. So let's go ahead and pick that. Let me just move my Zoom screen. Okay, hit next. Now we get to choose between 3 different types of races. You can say time trial, racing against the clock, avoiding certain objects. You can make these objects static or dynamic, or you can do head-to-head racing. So head-to-head racing sounds fun. Let's train our car for that. Let's say that there's 2 other cars on the track. Let's say that they have a speed of 2, and they can change lanes randomly between 1 to 5 seconds. Now, you can customize your car. I have a car that I created before. I called it Super Mario, but this is the newer generation of a car. It has a stereo camera and the LiDAR as well. So we're going to go ahead and use that. Say next. Now the next thing it does is we have to create a reward function. So our reward function, this is where we specify what type of behavior that we want our car to do and how we reward it, right? So we have some examples that you can play around with over here. Let's say for head-to-head, we have an example over here. You can use, or you can take advantage of any of the other examples. You can see what they do. The head-to-head one lets you stay on the lane and not crash. The time trial lets you follow the center line. So based on what you're trying to do, you can play around with the reward function. They all have different types of parameters that you can play around with as well. So let me just showcase those parameters right now. And so right now I'm going through that website that showcases the different learning aspects of reinforcement learning. Okay, so these are the parameters that you get to play around with in your reward function. So you can see the position of your car on the track, the heading, waypoints on the track width, distance from the center, are all the wheels on the track or not, the current speed, steering angle, and I believe there's 2 more there that you can play around with. So those are the parameters that you get to adjust and use in your reward function, which is just this Python function over here. In a simple case, if it's a time trial, you can go ahead and follow the center of the line, or play around with whatever you want to do over here. There's a lot of resources on how other previous winners have modified their reward functions when they competed for races, and you can take advantage of that as well. So that's the reward function. From here, you can't, right now, you just have one network that you can use, PPO. You can adjust your hyperparameters accordingly. Right now, I keep this at default. You know, things like entropy can go ahead and change how many random actions your car takes. So if you want to learn more about what you can do with hyperparameters, you can click on info and see how that affects your training. So for now, leave that default. Stop condition, you can adjust it this anywhere from 5 to 5 minutes of 24 hours. You can train 3 models concurrently as well. So 60 minutes is not the best for this. I've seen 180 and above gives you better accuracy for your car. But for now, you can choose whatever you want over here. I already have one running, so I'll showcase that. So let me go ahead and create this model. The first thing it's going to do, it takes a couple of minutes to initialize to bring all the infrastructure to train your model. After it's done, it'll shut that down as well. So let me showcase a model that's already training right now. So you can see right now a model that I started training before this talk. On the right-hand side, I'm using that Super Mario car. It's not doing a great job right now. Every time it goes off track, it restarts over here. But it's just still learning right now. But you can see this is how it looks currently. On the left-hand side over here, you can see a couple of different things. You can see how the average reward is over time based on the color. You can see the percentage completion in this blue line over here. And then you can also see percentage completion for evaluating this model. So it's kind of hard to see with multiple. It's definitely easier to see with one graph at a time. And that's essentially the DeepRacer. Any questions on the DeepRacer so far? Perfect. So those are all 3 of the devices over here. If you do want to learn more for the DeepRacer, there's some more resources. You can go to join.deepracing.io. Again, we have GitHub workshops and samples that you can use to learn more. And if there are any questions, also feel free to email me as well. I will put this presentation on the Meetup page too. And then one last thing, I wanted to have an Oprah moment over here. So I know, sorry, Ken, I know that you're raffling off 2 $25 credit codes, but everyone here is going to get a $25 credit code if that's okay.
That's awesome.
Yeah. So what I'm going
we
to
don't
do
look at posters in the mouth here.
what I'm going to do is just send you a sheet right now. I see there are 37 participants. Maybe I'll just give a couple of more, and then I'll just send that over to you. And then you can go ahead and distribute that however you like, or people can go ahead and email me, kbatra@amazon.com, whatever you think makes sense for this.
I'm going to say it might be simpler if people reach out to you directly rather than have 37 people email me and then I email you and then you email them back.
Perfect. Perfect. Okay, guys. So if you do want credit, it's kbatra@amazon.com. Feel free to go ahead, play around with Ground Truth, DeepRacer, DeepComposer. If you like it and you finish those credits, just don't tell anyone. Just reach back out to me, and happy to give you a little more if that helps. I'm here to be of assistance. If you need anything else, please just let me know. Hope you enjoyed the presentation. Hope you learn a little bit more. Thank you.
Thanks so much. That's fantastic. That was really interesting and diverse. We got to touch on a lot of different things. One quick mechanical note I might just suggest, if people email Kunal, maybe just put Boston Meetup in the subject so that he has a way to filter and group all the emails coming in amongst the hundreds of others.
Awesome. Thank you so much. Again, kbatra@amazon.com, and I'll just stop sharing my screen.
A couple questions. First of all, thanks. This is awesome. I mean, I really enjoyed playing with the DeepRacer, and you don't actually need the physical device because,
Yes.
as you said, everything is just training. And it's funny. There are all kinds of resources you can get started with on doing a reward function, and it was interesting to me to see how some people took it to extremes, because like we could get a couple of us got our car, so we could reliably finish the track in 30 seconds, and the winning score was like 8 seconds, so we were just completely off. But we saw people who were have their Python functions invoking lambdas to do steering into the turn and skidding and just sort of ridiculous degrees of getting into it, and the training credits will absolutely help, because 1 hour of training, that's great, but 10 hours of training often will do much more.
Is there a point where you can overfit the model, and so you become really good at the training track, and then you can't do the others? If you ran it for 50 hours, would that overtrain you? So
Yeah.
is that one of the optimization points?
Yes. Yeah, no, for sure. Yeah, you don't want to overtrain it too much on one specific car. I don't know if anyone here has competed actually at reInvent or any of our summits, but you'll definitely notice that. The other thing is that there's a difference from training in the simulated model and using that to run a community race online, and there's a difference from using that same model and running it on the actual car. You're going to notice weird things like lighting makes a difference. A lot of other things can make a difference on that actual track. So there's definitely, it's really taking a look at that track, that simulated model, and trying to see how close it is to that to actually get the best results.
So is the field of view of the image, it includes area above the horizon, right? So is that, in the official tracks, is that sort of normalized out with a barrier, or do you actually see sort of varying backgrounds?
So it depends. We try to keep it pretty standard when we have our races on the summits. But that field of view is just the photo from the camera, right? So that's a 120 by 160 pixel camera. If you have the newer car, it's a little bit better. It's 120 by 160 times 2, and then you have the 90 degrees behind of it from the LiDAR as well. So you have a lot more data with the newer car, but the older one is just that square little photo that it's taking a look at. So we've seen instances where one of the judges is wearing black shoes, and then from there the car thinks that's part of the track, so it starts going over the shoes as well, right? So it's important. It's only taking a look at a really small field of vision.
Yeah, I remember, I mean, many, many years ago, watching a demonstration from University of Maryland, doing some computer vision, not machine learning, but there's a really interesting example with the way the shadow worked. It drew this really sharp line, and this auto-driving car in like 1985, I think this was, just drove right off the road because it's followed the shadow.
Yeah.
We had actually we were trying to do something a little different at my last place. I wanted to set up the car to drive from our reception area to an interview room so that we could have interview candidates be taken to their room by the car. But oddly, they would not let me put all kinds of duct tape all over our carpets. And so, the car is very, the models are very much set up for, I think, black track with white borders. And I'm guessing if I went into SageMaker, I could adjust that, but that was beyond me at the time.
Kunal, I have a general machine learning question for AWS.
Yes.
As far as the AMI, so the images for the EC2 instances that can be used for ML, I noticed that there's some that already have CUDA built in for the GPU enabled EC2 instances. Is that already integrated with the individual frameworks that sit on top of those as well?
Yeah. So the AMIs for EC2 are integrated with the frameworks. Now, these EC2s, they are for the deep learning containers. I believe that only has TensorFlow and MXNet. It doesn't have support for PyTorch. But for the EC2, for the AMIs for that, it has support for all the frameworks.
So okay, so I can't get an AMI with PyTorch support for it, is what you're saying.
With for the AMI, you can, not for the containers. If you're trying to use EKS or ECS instead of EC2, that won't have PyTorch support. But for the EC2 instances, it does.
Okay, cool. Thanks.
Two other things. I was wondering if you can share or say a little bit more about the garage door system you had, and the other thing for the other when you talk about detecting objects around the house, I'm wondering if you could have your network of cameras see what was the last place it detected someone put their keys.
Oh yeah. So for the garage door one, this was an issue, a really small one, but I noticed my parents were like, "Oh, did we close the garage door? Did we not drive back in?" And the first thing I thought was, "Oh, this is simple to solve. Let me just take a bunch of photos with the closed, not closed, train a model on it. Then I put a Nest Cam there, right?" So this was before the Deep Lens. Well, this is before I had a Deep Lens. So put a Nest Cam over there. Nest Cam has an API where you can just go and get an image. And then from there, you can set it at a certain interval, go ahead, run it through your model, see if the garage door is open or closed. And then they can get a text message on their phone letting them know whether the garage door has been open for longer than 5 minutes. So it's a fun little use case, just showcasing image classification, and it helps them out, let them know if the garage door has been open for longer than 5 minutes. And for the detection one, what were you asking?
I just had the notion of, and it would involve maybe too many cameras, but I think many of us lose various things in the house, and if the cameras could say, hey, every time it saw keys or a phone, pay attention to where it saw it.
Yeah, that would be a great Alexa skill, right? Hey, where is the keys? So yeah, that's totally doable. The only thing is you would need angles from all over different parts of your house, and it won't see things that are not seeable. So I guess your question is if it goes in between the sofa, the last place it was seen was the sofa, right? So I guess that would work. Yeah, no, that could totally work.
Yeah, put cameras on your ceiling of every room.
Yeah.
So there's a couple of questions, or at least from the chat. Bill is asking, oops, scrolls away. Basically, what's the best DeepRacer time compared to the computed best possible lap time?
Oh, good question. I don't have this off the top of my head. I believe it was a team from Japan that had the best DeepRacer time in one of our summits. I'm forgetting the exact time right now. If you go to DeepRacer League, you might be able to find the actual times right there.
The woman from Japan that won this past year, it was like 9 seconds or 10 seconds or something like that for the lap, I think. Does that sound right?
Okay. I feel like was that the case, or was it a little faster? I wasn't sure.
I was just having a conversation with someone.
I guess the real question is, because obviously the different tracks, but how close are the best players getting to the ideal possible speed?
Yeah, good question. I'm not sure what the exact difference is here. I know it's always slower in the real life scenarios, right? Because the real life scenarios, they're never identical. Even at reInvent, depending on which track you use, you could have different results, right? One of the cars, the shadows might be a little different, which affects the racetrack. So it's always different from real life to the simulated. So there's definitely going to be slower for that.
Hey, Kunal, just a quick question. I know you've built this at different levels, from infrastructure, or rather from low-level library support to sort of platform level support to then application level support. And a lot of the stuff gets hidden behind some of those quick checkboxes and menu options. But if we were trying to look at, say, classifying sound based upon or multi-source sound, and then apply classification, and then sort of utilize that to then sort of distributedly detect it across, say, individual or multiple sources based upon what was available in real time. And I can sort of go on and have like other such problems. How would you say you would tell people to go about cherry picking which layer to sort of start using this? Because it seems like a lot of the complexity is hidden behind, and by design, of course, right? So, and
Yeah. So good questions here. So audio detection classification is not something that I've done a lot of. But what I would say is start off with your data set over here. You're going to need that data set to train with. I don't know if that's something that you already have, or there's an open source data set for it. Ground Truth is a great way to get that data set labeled. Or there's a lot of open source tools similar to Ground Truth that doesn't have that workforce component to it though. Get that data set labeled. SageMaker, I don't know if there's any audio classification algorithms that can do that. I mean, I would assume that you're breaking down the sound into some sort of tabular data. And then
yeah, it's basically running for Fourier transforms.
Fourier transform, yeah.
Yeah, so, yeah, I mean, I've thought about this a little bit. I think what you're getting at is most likely you're going to get into a SageMaker notebook and think of it as just tabular data. So one way to sort of ease into it is sort of basically build a really simple CSV with not audio data, just to kind of get used to it, and you build a predictive model, if that's the kind of thing, or a classification model, just using some simple thing with movie titles or whatever. Once you kind of get that in your head, I found that if you can just take your audio data and just map that to the same thing, so you have this vector of frequencies varying over time that you get from an FFT or something like that, and then you could basically you can dimension and do different types of audio analysis, but just have it be a vector of numbers. So you can do capsual analysis or FFTs and other types of transforms, and just do your own feature extraction of the audio, and then it's just numbers like any other thing, just like genetics or genomics or something like that. What I haven't seen yet is great ways of just doing like a CNN on just raw audio samples.
And just to add on to that, let me just share my screen really quickly here. So we do have a service called Autopilot. I don't know if everyone here is familiar with it. It's actually really cool. It's part of SageMaker. And this is one of the data sets from the Autopilot demos. And basically, let's say you have your tabular data. In this case, the tabular data is different features of a customer, and then whether they accepted a marketing promotion or not, a marketing campaign or not. With Autopilot, you don't do anything. You just upload this data set to S3 and you give the location of that data set. And then Autopilot will just ask you for the location of the data set, and then it asks you for which column do you want to predict on. So over here, we say, do we want to predict on this column Y, and whether they accepted a campaign offer or not. For your case, I'm assuming this is classification. If it is, then it doesn't matter what those features are. It'll go ahead and automatically know that this is either classification or regression based on your data set. And then from there, it will go ahead and train it. It will look through multiple models to find you the best one. And then after that, it'll give you a list of those models, different accuracies and how well it performed. And then it'll give you a little button next to that model to deploy as an API endpoint. So if you want to take a look at this, I recommend checking out Autopilot. Essentially, you just need this tabular data. It doesn't matter what's in there, and it takes care of everything else for you. The other thing it does, if you don't want to actually deploy it, it'll give you a notebook of just telling you its understandings, and these are the different models that it tried and how well it worked. So it's not like other AutoML solutions that are just black boxes. It will actually walk you through the thought process behind why this model works best for your type of data. And that's really easy to use. So if you just go to SageMaker, basically go to SageMaker and then click on SageMaker Studio over here. And it's a quick little box. It just says Autopilot, and it does everything else for you. I definitely recommend it. It could help with your use case. Pretty
awesome. Once it picks a model for you, will it also tell you which columns were most predictive or at all predictive?
So you can take a look at it. It'll have a notebook there that walks you through the understanding of its data, but it only predicts on the column that you tell it to, right? So you just give one column, and then it'll either do classification or regression if it's continuous, like if you're trying to predict house prices or temperature or something like that.
Right. Well, that's on the label, but for all the attributes.
Oh, like which one was the most weighted in terms of what it looked at?
Yeah,
I'm not sure.
Because I'm sorry, what was that?
I'm not sure. I'm not sure if it'll give you which one had the best weighting or most impact.
Yeah, because what you'd like to be able to do is throw a whole bunch of attributes at it, and then if it turns out a whole bunch aren't useful, especially when you're doing audio, you might decide, I just don't even want to compute these columns if it turns out the model's not really going to use them.
Yeah, I haven't tried it with audio, but I recommend checking that out. Let me know.
Does it also impute or give you the option to impute in case you have multiple vectors, or like typically if you're pruning using SVG or something, you can also, in certain cases, if you don't have enough granularity, can you impute based upon what you actually know about certain parameters beforehand?
I don't know. It doesn't have that much customization to it. It's pretty much you kind of give your data, and then from there you get a classification or regression model out of that.
And to an earlier point, is it auditable, right? Like, can you sort of ask it questions, how far you ran, which model, where did you stop in terms of if it's an ensemble, if it's using multiple models to do it?
Yeah. So exactly. So it gives you two different notebooks. One, it tells you the understanding of the data. The second one is, here are all the different types of models it tries. I believe it has a pipeline of, it chooses the 7 best from what it thinks from your data, and then from there it runs all 7 of those in parallel, and then it tells you how well each one of those did.
So I'm going to jump in and just mention that, so thank you, that was awesome. Really enjoyed it. I'm also going to say that we have our next meeting is in 2 weeks. We're maintaining our every other week cadence in these crazy times. Our next meeting on August 13th is getting the most out of DynamoDB secondary indexes, and we are incredibly lucky to have Alex Debris, who is the Dynamo person. he's literally written the Dynamo book. And so that's going to be very cool. Any other questions, or are we around?
I'll just say, encourage everyone to join our Slack. I think I posted the link earlier in the chat session. So always good to get everyone there. It's good for some coordination, but also to start building community. There's a few discussions, but more people, the merrier. So that would be great. Also, if anyone wants to give a talk, even if it's just a short lightning talk, just to get some experience or to share something that you're interested about, we're always looking to try to do that. So we bring in experts like Kunal, which is in Alex, which is great, but also happy to give the spotlight and some opportunities for local people, part of the community. So if you're interested, contact Jen, Brian, me, and just let us know your ideas. We're wide open to anything. It could be short, could be long, whatever makes sense.
Okay, well, again, thank you so much. That was so much fun. I may go back and try to dig out my old DeepRacer model and start playing with it again.
Oh, and Brian, if you'll send me the recording, we'll post it up to YouTube and I'll announce it on Slack. Usually it takes us a day or two to get to it. I'll certainly by the end of the weekend for sure, but probably on Saturday I'll have it uploaded.
Right. It takes my poor old MacBook quite a while to chew the recording. Okay. Well, thanks everyone. Enjoy the rest of your evening.
Thanks, Kunal. Thanks everyone for joining. Thanks, Brian.
Good night, everyone.
Thank you.